Redgate!
Thank you. Thank you. This is really going to be fun. First of all, I am really happy to see you here. This is such an amazing event that you have created to engage new speakers to the community. And there is many great session lines up for today, that I am so humbled that you have dedicated some of your time for this session. And here is a funny story. It was very, very close that this session never did see the light of day. Let me tell you about my adventures with PowerPoint. You know the story of how the dog ate my homework? Well, that's exactly what PowerPoint did. 2 weeks ago, from 1 second to the next, PowerPoint had gobbled up my file and there was no backup anywhere. Not only had I enjoyed the stress and challenges of creating my first ever session for a conference, I also had to deal with losing all of my work at a time when I really didn't have time to make a new one. I was just about ready to throw in the towel and just walk away. But then something amazing happened. My mentor whispered in the ears of a few members of the community, explaining the situation I was in. And suddenly I had a torrent of well wishes and encouraging words in my inbox from people I have never met. These acts of kindness showed me in a crystal clear way how amazing the data community is. These people believed in me, so I simply had to dig out my post-its and get back to work. And here I am. I might consider doing my next session on backups. Let's dive into the actual session. My hope is that you'll leave this session with a new outlook on an established truth. Just because we've always done something in a specific order doesn't mean we should do it in that way tomorrow. So I'm going to tell you about how my first experience with Azure Data Factory came to be. I work for a consultancy company and we do many different kinds of projects. And about a year ago, I was placed in a project that included ADF as one of the tools. At that time, my only knowledge was how to create activities and the main purpose of the tool. The senior of the project developed all of the pipelines, all of the activities and the parameters and so on. And then she had to move on to the next project. So there I was, all by myself, even more so because of the ongoing pandemic. So everyone worked from home. I found myself in an environment where I was meant to continue the development and to manage the solution. And I guess you know where I'm going with this. So what do you say when I also tell you there was not a single line of documentation? It didn't take long until I ran into big trouble. So I had no choice but to learn every bit and piece of the solution. And to do that, when you are totally new in the industry, in the tool itself, and in an environment you haven't built, and you're supposed to write the documentation about, that's a big mountain to climb. So it was time to put my big girl pants on and get to it. So who am I? My name is Linda Torrång, and I'm working from Stockholm, Sweden, for a company called Atollo AB, where I am a data warehouse and business intelligence developer. My background is probably not what you would call a typical BI background, as my experience comes from journalism and later on retail. But I have what is most important in this industry, a strong desire to learn new stuff. So in my early 30s, I went back to school, and from day one, studying business intelligence, I loved it. And if it wasn't for my ridiculous love of Star Wars, I wouldn't be here today. Because that's what led me to my mentor, very good friend, and just recently, new colleague, Alexander Arvidsson. So thank you, Alexander, for bringing me into this world of data and public speaking. Well, the agenda for today, we are going to establish what I refer to as an implementation patterns for the real world, how to adapt to it, and build for it. For those of you that don't know what Azure Data Factory is or what it can do, you're gonna get a really fast, really high-level introduction. This picture is taken straight from Microsoft website and does a really good job of explaining the bits and pieces of Azure Data Factory. The trouble is, there is a lot to take in. So let's break it down a bit. Simply put, Azure Data Factory is a cloud-based tool that can transport and transform your data. That's it. It can do so in a more or less complicated way. But at the end of the day, that is what Azure Data Factory does. For starters, we're going to look at Azure Data Factory as a data movement tool. You grab your data from somewhere. This is called a source, and you drop it off somewhere. That's called a sink. In order to connect to the source, there are a few things that need to be set up. For starters, we need a linked service. This is essentially a connection from Azure Data Factory to your data source. Said data source can be anything Azure Data Factory has a connector to. Just about anything you can think of. In this example, we can set up a linked service to a blob storage to use as a source. And by setting up another linked service to an Azure SQL server, we can sync the data from the source into that. This linked service works pretty much like a connection string to whatever external data store you want to use. If you fetch your data from one place like a blob storage and are going to transport it somewhere else, you need a linked service for each connection. Unfortunately, it is not quite simple as that. What if we have a multiple blob stores or several databases on the same SQL server? Yep, we need one or more level of control. Enter the dataset. This is an exact pointer within your linked service, like one of the two databases in the same SQL server host, for instance. Now we're getting somewhere. But we also need to decide on how we want to use Azure Data Factory. There are 3 options for the so-called integration runtime, i.e. how the compute resources used for data movement and transformation should behave. The first one is called the self-hosted integration runtime. Don't worry, it won't be parked in your own on-prem environment, but it is designed to be able to reach into your on-prem environment. And thus, use is the choice for hybrid scenarios where data needs to be moved between on-prem and the cloud. The Azure integration runtime, on the other hand, is designed for inter-cloud data movement and brings some things to the table that the self-hosted integration runtime does not. This is a quick overview of Azure Data Factory, so I won't go into details. But the Azure integration runtime is the only runtime capable of running so-called data flows in Azure Data Factory. And finally, we have the Azure SSIS integration runtime. We kind of recognize SSIS from the old days of SQL Server integration services. And indeed, that is exactly what this is. It gives you a way of running old school SSIS packages inside of the Azure Data Factory. And while it works, there are both a ton of caveats, but more importantly, there are potential cost implications. All right, all done. Let's turn this on. But wait a minute. So far, we've only set up the infrastructure, connected the cables, turned on the power. We have yet to define any work. Time to take a look at the pipelines. Pipelines are like packages that contain specific tasks to be performed by Azure Data Factory. And as with most everything else in the Azure Data Factory, they seem simple enough, but turn out to be able to get pretty darn complex, pretty darn fast. A solution is built with pipelines, and a solution can contain one or more pipelines, and every one of them may or may not have sub-pipelines. You can think of a pipeline much like a train, where you place your cars to be moved in the right order. The engine is the main pipeline, if you have one to rule them all, and after it comes cars of sub-pipelines, and in every car there is cattle, aka our activities, and the fleece on the cattle is our parameters. The sub-pipelines, or train cars if you may, can be executed sequentially or in parallel. Activities can be anything like a lookup or a copy data, a store procedure. You can set or append a variable, or a switch, a filter, for each. You know these kind of things already. So yeah, there's a lot you can do. And as I told you earlier, in my example, we are mainly looking at transporting data, not so much transforming it. So we have mainly used lookups to know which source we're dealing with and to log some information. On to a copy data activity to establish the source and destination, and then a store procedure to insert new and updated current data. And to finalize the chain, we have two different store procedures, both executing the same procedure, but depending on if the previous step was a success or failure, it produces information about how many rows that's being transported and other useful information for you to know. And just for your information, this is just a teeny tiny part of the whole pattern. This is one of the sub-pipelines. And then you place your triggers on the pipelines if you want them to run automatically. There are currently three ways of triggering a pipeline, either on a schedule, like a wall clock, or you can have a tumbling window that operates on a periodic interval, or through an event-based trigger that responds to some kind of event occurring. And there you have it. That's the main components that need to be established to get a data factory up and running. But reality is harsh, cold, and often rather frustrating. The point of an implementation pattern is to make sure that the things are done in a consistent and well-documented and efficient manner. Keywords are reuse, consistency, and adaptability. But that was the issue in my case. These were just words, as I didn't know what had gone into creating the pattern in the first place. There are several ways to create a solution. Some good, some not quite as good, but each and every one of them has its own purpose. And that's one of the things I concluded at this point. You have to figure out the problem the pattern is a solution to. I'm going to say that again. You have to figure out the problem the pattern is a solution to. Then build towards the solution, not only following the pattern handed to you. And the more I looked at this, the more I realized that an implementation pattern is but one side of the coin. The other side of the coin is the why. Why are we doing this? What are we trying to solve? Just like in IT in general, never has a purpose of its own, but is always a support structure for the business. The architecture platform is but a tool to be used to further a goal. The pattern is not the goal in itself. And if the underlying philosophy of the pattern is shrouded in darkness due to either poor documentation or, as in my case, lack of experience, it's easy to fall back to just trying to implement the pattern and to hell with the consequences. The idea is sound. The company used their brightest minds to come up with a reusable architecture pattern, canned and ready to implement. Really doesn't matter if we're talking about data factory patterns or just a pattern to build a data warehouse, no matter the tool. The idea is literally a shake and bake solution to do a problem. A standardized solution to make sure you deliver a correct and clean result is just common business sense. If only every problem was the same. Unfortunately, this is rarely the case. Reality is messy. Two customer projects are rarely going to behave the same way when push comes to shove. But from enough altitude, they might seem to be the same. And here comes the fundamental issue with a fixed implementation pattern. It is somewhat inflexible. Your pattern is only as good as the person implementing it, because it's really impractical to bring a chainsaw to a dinner table when you only need a table knife. A great solution can most probably do the work for most situations. But if it doesn't have to, a small project for a customer who doesn't need all the stuff that a big project needs would probably not be happy to pay for all of that. A more intricate solution pattern will not only take more time to implement, it will also cost more, as well as have a multitude of moving parts that all need care and comfort. So you need to be able to scale your solution. Since scale is only an euphemism for flexibility in this case, we're back to flexibility in a pattern. That's what an implementation pattern for the real world is. And I'm going to walk you through some key points that you can use to decide which level of complexity you need when developing a pattern in ADF. First, let's go back to where I was a year ago, when this session started taking form in my head without me knowing it. I didn't know much about anything in ADF, but I do know business. And I realized quite fast that the way I went about learning things from scratch wasn't the most effective one. I didn't really know where to start, and I sure as heck didn't know quite where I was going. I literally just doubled down and moved the only way I knew, forward. And what was the way forward? Smash it to pieces. A million pieces to try to figure out what the pieces there were, how they really fit together, and most importantly, why they were there in the first place. So, armed with the Microsoft documentation and an unhealthy dose of let's poke at stuff and see what bleeds, I went back to the pattern and tried to make sense of it. It went about as well as you could expect. In time, I learned how the pipelines worked and what the activities did. Things were starting to make sense, but the number of pipelines and activities I was going to need was becoming an issue. With no background in integration tools like SQL Server Integration Services, I didn't quite grasp the corner I was painting myself into with this way of creating a solution. Then I stumbled upon parameters, and it dawned on me that this might be the solution to the coveted flexibility. This seemed to be the key to automating stuff and not having to endlessly repeat all the pipelines and activities for different scenarios. This way, I could build the mother of all pipelines, the one unicorn that could do all of the things. Doesn't get more flexible than that. Here's what makes parameters so great. In every activity, you can set a parameter, as few or as many as you like. They can also be used globally at the pipeline level. Setting parameters up here means that they'll have an effect on everything in the pipeline, meaning that the need to endlessly duplicate settings over and over again just went the way about the doo-doo bird. A parameter can be explained as a pointer to something that you could twist and turn according to your wishes. For example, you could set a parameter for a data set and then use the same activity for different sources simply by changing the parameter. This has enormous potential, as all the almost identical activities and pipelines we built so far can be reduced to way fewer activities, maybe even one. In fact, this is where most projects where a member just discovered parameters is heading. And that might not necessarily be a great thing. When you realize the power of parameters and their effectiveness, you get carried away quite fast. And that's where you could get lost. Because then you might start building the solution with parameters to control everything. And while we're at it, produce a lot of extra data, such as monitoring information. With this flexibility, unfortunately, comes complexity. And while this might be an excellent idea in a big project, it might actually turn back and hurt you if the scope of the project is small. It is vital to step back and try to determine what you really need. If a super complex solution with a gazillion of parameters is the right way to do it or not. Just because you can doesn't mean you should. This takes quite a bit of self-control. I'm the first one to admit that. So, given that we can create anything from an infinitely duplicated contraption with an abundance of an almost identical pipeline to a highly parameterized marvel, how do we figure out what a reasonable level is? What questions do I need to ask myself and the customer? Do we have a budget to adhere to? Are we facing a hard deadline? Should it be a super solid solution from the get-go, or could it grow over time to become fully developed? All of us want a project that can deliver on all three corners at once, but that's not doable. So pick at most two, maybe even just one. To do this, you have to get to the essence of the customer's needs. We move beyond the code. We move beyond the technology. We move beyond the pattern. Here, where we're starting to glimpse how we can evolve a pattern into a solution. We need to figure out what requirements are must-haves and what requirements are nice-to-haves. Most of the time, I find that a lot of requirements start out in the must-have, only to be moved to the nice-to-have after time goes. Time, cost, or other limitations make themselves known, and you know which way to go. Spending time in this phase will almost always save time in the implementation phase. Penny of prevention is worth a pound of cure, as the saying goes. So take the time and really conclude what is the absolute must-haves and what is just nice to have. Maybe you need to keep to a certain fixed budget, and that trumps the timeline, or the other way around. Figuring requirement is an art in itself and something that could easily warrant a session or two on its own. Okay, so let's recap quickly and see what we have in place so far. We have the pattern, we have some knowledge, and we have figured out the basic requirements. We're getting there, but we're not quite there yet. We now have the required information to answer the question of how complex a solution we want to create. Remember the limiting factor from previous. We might be constrained by budget, time, or something else. How does this apply? The first question, when the time comes to actually start building a project in Azure Data Factory, is whether to build a static solution or a dynamic one. We've touched on how parameters enable you to create a more flexible but potentially more complex solution that minimizes duplication. Now, a static solution is by no means automatically a bad choice. In fact, you might start with a static solution and develop it over time to a more general and dynamic one as the requirements get firmed up. Then again, if the project is firm from the get-go, it might save time to implement a thoroughly parameterized project from the start. It all depends. So what is this static pipeline thing? Let me show you. A static pipeline might very well not need any parameters at all. It might just consist of a hard-coded source and a sync definition, pretty much like this. It is literally a copy data activity for a specific table, being sourced from somewhere and sunk into something else. Dead simple, and it might just fit the bill perfectly. But the problem is that this won't scale very well when you need to make several similar pipelines. In fact, it becomes not only tedious to work with. Anyone who has ever worked in the Azure Data Factory Studio knows how much fun it can be to copy and paste pipelines, but also susceptible to errors. I mean, consider what would happen if you need to change the source definitions to point to another blob storage. It would need to be done in every pipeline. It's easy to see how a mistake could be made that could derail the entire day. Then you might instead need to go towards a more dynamic solution. And a dynamic solution could consist of a few parameters that might just be a dynamic source and destination. Or it could be very complex with many parameters for several different purposes. A good thing to remember is that the dynamic solution will take longer time to start getting things into place. And it will be more complex to troubleshoot. Having said that, you will most probably gain back the time you lost when implementing the more complex dynamic solution when the number of pipelines start to increase. The upfront cost will be large, but the potential saving going forward will be worth it. A hard-coded static solution can therefore be useful for a small project when you need to get things up and running fast. Here are some questions to help you figure out which direction to go to. Is it a one-off thing? Are the transports only going to happen one time? Not very common, but it happens. Or will this be a continuous solution that needs to be maintained? Is your solution going to grow? Can you see a future when more things will be implemented in the solution? Should we build for a scalable solution? Is the number of tables and schemas involved low? If it is just one table or schema, then you don't need parameters, because then you could point to a certain schema or even a table. You don't have the need to be flexible with it. Maybe you just need a wildcard. Is the source and destination static or likely to change? If you always fetch us from the same source and send to a destination that can be different from the source, but the same destination for the things you transport, then you don't need parameters to be flexible with your datasets. Do you need to keep track of pipeline execution? If you want to log how many rows you're transporting, or just if the execution was a success or not, then you might need to set up your own solution for it instead of relying on the monitor in ADF, which by default only saves for 45 days. Those are some of the questions that you can start off with to establish a static or a dynamic solution. If you are going down the dynamic route, the question then becomes how dynamic? Just because you can doesn't mean you should. In my mind, we should have a base pipeline. One pipeline to rule them all, to do orchestrations, start small and build your way up to a more complex solution. That way you can make sure you only have what is actually needed to build the solution you're aiming for. Instead of using everything in the kitchen sink from the beginning, something like this, basic, easy to understand, and simple to develop further. We can add on things from that simple starting point. For example, activities which can produce some logging information, or why not a dynamic source parameter? Or we could make it even more activities to log as much as we want. The sky is the limit. We are in the cloud, remember that. So going back to my train wreck of an introduction to Azure Data Factory, I faced a huge pile of Legos. I probably wouldn't have learned as much as I did if I had any documentation in the first place. But with that said, wasn't a very pleasant way to learn at all. I had to break down every bit and piece of the solution to understand what it did, where it came from, how it worked, and why it did it or it didn't do it at all. Then I had to try to piece the whole thing back together again. But now I had much more to work with. I even had a fairly decent instruction manual explaining how the pieces fit together. So how do you build anything in Lego? Well, you start from the beginning, putting one piece on top of another, and time to figure out if what I had learned so far actually held up in reality. The issue with the instruction manual at this point was that it still was somewhat inflexible. I had the pattern, I had the skills, and I had the requirements from the customer. But something still felt like it was missing. I mean, I would be quite capable of actually implementing the Azure Data Factory project with the information I had collected. But I really hadn't done anything differently from when I was throwing myself into the deep. I was lacking the final piece of the puzzle to turn a pattern into a proper real-world solution. I was lacking instructions for building variants. I have already mentioned this several times. In my view, the documentation is just as important as the solution itself, no matter what you build. The thing is, you don't really have to write down every little detail. One of the best things with working in Azure Data Factory, or anything in Azure for really, is that everything literally is infrastructure as a code. Everything inside of your data factory can be expressed as a JSON code, which means that the infrastructure setup is just about self-documenting. What is not documented, however, is why the solution looks the way it does. And that is the difference between starting from zero, trying to figure out everything by trial and error, or hitting the ground running. I had faced the former, and I didn't want to put the next Linda to come along through the same ordeal I went through. Not only for her, but this documentation will obviously also come in handy for the customer when they try to make sense of what they have, as well as any other developer being asked to expand on the solution in the future. The most important thing that's more important than any kind of high level or granular documentation is to explain the why. Just consider being handed a document that clearly explains the choice of one design philosophy over the other. You might not agree with the choices made, but you don't have to tear your head out trying to understand how someone could come up with a solution like this. Remember the decision tree from before? Not only is it useful for figuring out which way to go, it is also perfect for putting into the documentation. Visible and easy for everyone to understand why you made the decision that you did. While we're at it, why don't you throw in some cost estimates to show what difference between the solutions would be at the bottom line? Heck, you could even have a list of the competence levels of the ones involved. What can we make with the resources at hand? It could even be great for you to circle back to a year later and evaluate that was the purpose and conditions at that time. Have they changed? Just see to it that you explain the why of the solution. Then, of course, someone like me will love to have all the parameters explained and what they do, but that is not the primary need. If within your organization you have the kind of solution pattern that we do, then it might also be a good idea to have a documentation explaining your base pipeline and the additions and subtractions that could be done with it. View it as another step into establishing a great pattern. New colleagues get to know the bits and pieces really quickly and easily and know how to adapt the pattern to the challenges faced. The thing is, this is not only for junior developers trying to learn how to implement pattern, but also for the more senior developers looking to add their own box of tricks. As with everything, the longer we work on something, the more ingrained and taken for granted it becomes. Until the day you either come back from the vacation or simply have been away for the project for a while. Some people say documentation is uncool. Well, I think it's pretty darn cool to be able to pick up where you left off without having to spend a buttload of time figuring out what the heck you were thinking last year. That's great business all the way. And as we've seen, it is a great idea to sell a ready-to-implement package, but a pattern itself is not a complete solution. It is part of the solution, but not the solution itself. Combining a pattern with skills will give you the ability to write the code. Adding the customer requirements to that will tell you what might need to be changed in the pattern to better adapt to it. Adding a good documentation explaining why the pattern looks the way it does will finally give you the last piece of the puzzle to turn the pattern into a proper solution and implementation pattern for the real world. Take that box of Lego, twist and turn all the pieces you're so familiar with and build what you need, not what you're used to. And if you're lucky enough to have a manual for the different level of complexity, then you're halfway there. So, to recap, a solution pattern is great to have, but you need to be flexible with its content. Build for the need, not what you're familiar with, not the things you find cool. When you can work beyond that, that's when you build for the real world. Don't bring a chainsaw to a dinner table. Bring a machete. Or bring a pocket knife. Or my personal favorite, bring a lightsaber. Just bring what you need. And what I learned is that you should never make it harder than it has to be. A million of parameters won't make it a better solution. Use the possibilities wisely and show off your skill by producing a solution that is actually adapted for the particular project. Make your implementation pattern work in the real world. I really hope you've gained some insights from this and that we all can agree not to build overcomplicated things just for the fun of it. And as the old rule says, less is more. My name is Linda, and I'm so thank you for listening.
Yeah!